This is the 2019 practice exam, and we're going to go over the multiple choice answer key for tonight. All right, so number one, and this is 2019 multiple choice AP practice exam, and they're asking about delta S. And as I mentioned, delta S is a measure of entropy. And remember that little degree sign up there? That stands for standard, so that's a reference value. So you're looking for something where the entropy is increasing. So even though we haven't gone over this, we can kind of see that the first one's liquid to gas, that's increasing entropy. Solid to liquid, that's increasing. And C is solid to gas, that's increasing. The next one, D, which is gas to liquid, that's going to be a decrease in entropy. And just like when we were dealing with enthalpy, a decrease would be negative. So the correct answer is D. Number two, it says one of the three solutions listed above, which one has the greatest electrical conductivity, which has to do with being an electrolyte. If you remember in class, we did demos where I had that electrical conductor, and the only things that conduct electricity are strong acids and ionic compounds. Those are strong electrolytes. Weak acids would be weak electrolytes. So A is a weak acid, so that's going to be a weak electrolyte. That'll conduct a very little bit of electricity. B is an ionic compound. C is a polar covalent compound, not going to conduct electricity. So the correct answer is B because it's ionic. 3. Oh, this is what we're doing right now, right? So they're in equilibrium. And then it says what will happen after the addition of iodine gas. So as soon as I add a reactant, it's going to shift towards the products, which is going to increase the rate of the forward reaction. And so the correct answer is C. Number 4, the first 5 ionization energy are of an unknown element are listed above. So remember we talked about the first ionization energy and the second ionization energy and the third ionization energy. That refers to the energy to take off the first, second, and third valence electron. So what you're looking for is a huge jump in the ionization energies. And you can see between the third and the fourth, there is a huge jump in ionization energies. So that indicates to me that the first, second, and third electrons are valence electrons, but that fourth electron is a core electron. So you're going to be looking for one that has 3 valence electrons. So the correct answer with 3 valence electrons would be aluminum. Sodium has 1, aluminum has 3, silicon has 4, and phosphorus has 5. Let's go back up to number 5. You're looking at water, and remember water has partially negative oxygen and 2 partially positive hydrogens. So you can kind of figure out that those white circles are the hydrogens, which are partially positive. And this is an opposites attract question. So you're looking for the question that suggests that the positive hydrogens are attracted to the negative, which would be an anion, and the answer is B. Number 6 is a kind of a lab question. So this was way back in the beginning of the year. We did the things that we could do, which were filtration. Filtration separates based on differences in states of matter. So filtration will separate solids from liquids. Paper chromatography separates based on differences in polarity. These are both nonpolar, so that wouldn't be appropriate here. Column chromatography is a similar concept. Distillation is the one you're looking for, and that's when we made that distillation apparatus. Distillation separates based on differences in boiling point. So the correct answer is going to be D. So let's reiterate that. Filtration separates based on differences in states of matter. Chromatography separates based on differences in polarities. And distillation separates based on differences in boiling point.
Okay, got it. Thank you.
7, the value of this is something we're in right now too. The value of the equilibrium constant for a reaction is represented above is 1 times 10 to the 10th, which is huge. Okay, so the value of the equilibrium constant for the reaction represented above is 1 times 10 to the 10th. What is the value of the equilibrium constant? Now, this reaction on the bottom is multiplied by 2. So that's actually, remember the coefficient becomes the power. So that's actually going to be squared, but it's also flipped. So the K for the second reaction is going to be 1 over K squared of the original reaction. So K squared would be 1 times 10 to the 20th, but 1 over 1 times 10 to the 20th would be 1 times 10 to the minus 20th. So the correct answer is A. And remember, you can do the K expression, which is products over reactants raised to the coefficient for both of them, and then compare them also. Number 8 talks about a catalyst. And catalyst, if you remember, they do take place in the reaction. They work by creating a new reaction mechanism and by lowering the activation energy. They don't actually change those. So you're going to look for ones that don't talk about the catalyst turning into something else. Like D says the catalyst decomposes. No, that's a chemical reaction, so that's not going to happen. Dissociates means it dissolves, and that's not going to happen. A talks about consuming byproducts of the reactions. That's a chemical reaction. That's not going to happen. So the correct answer is B. It binds temporarily to the reactant molecules to lower the activation energy. So that's how catalysts work. If you remember, we did the pink catalyst reaction in class where you saw like in the middle it got green, and we saw that with the color change, it changed to something else, but then it ended up back pink after all was said and done. So the correct answer is B. Number 9, you're going to expect to see something like this. When your crystal lattices, the particle pictures are going to have plus, minus, plus, minus, plus, minus. So the only one that's really the best representation of plus, minus is B. Here's another one we're going to go over quickly because we haven't gotten to this yet, but we will. This is an electrochemical cell. This is kind of battery science, which is huge. So in electrochemical cells, one of them will be reduced, one of them will be oxidized. So if you see, half reactions are listed as reduction reactions. So the more positive it is, the more likely it is to be reduced. And in this case, silver is going to gain the electron and be reduced. So the opposite's going to happen to zinc. So you flip zinc and leave silver as it is. So the reaction for silver is going to be silver plus an electron goes to silver, and zinc is going to flip. So you're going to have zinc solid as a reactant, and you're going to have silver plus 1 as a reactant. We'll get to how to balance it. That's going to be a little difficult to explain right now, but we did do balancing half reactions. So you might remember back to first semester, the correct answer is D. And because I flipped zinc, I would change the sign on that. So it's going to be plus 0.80 plus 0.76, and it's 1.56. And that's the part that's not likely to make sense to you right now, but we'll have some ways to remember that when we get to that part of the unit.
Wait, for number 10, is it just remembering how to do half reactions?
Right, the balancing of the half reactions. Because remember, they can't both be reduced. In order to have a reduction, you have to have an oxidation also. So you got to figure out, well, which one's going to be reduced and which one's going to be oxidized, and that's what we're going to learn next. But the other part of it is that balancing half reactions that we learned in first semester. But we will be reviewing that together too. All right, number 12. A little easy stoic, because remember, in this particular type of problem, you do not get a calculator. So a problem-solving strategy here is if you're trying to do super complicated math, you might be doing something wrong. So you're going to start with 880 grams of CO2. Then we know we're going to change grams to moles. So our first step would be 880 divided by 44. Can you do that in your head? That's if you can't do it in your head, obviously you'd write it on paper underneath, but your first step is 880 divided by 44 to get 20. So now you have 20 moles of carbon dioxide. But look at the balanced chemical equation. For every 1 mole of carbon dioxide, you need 2 moles of lithium hydroxide. So now you have 20 times 2, or 40. So you need 40 moles of lithium hydroxide at 24 grams per mole. So you're going to be multiplying 40 by 24, and the correct answer is D at 960. Okay, so let's look at 13. In 13, remember from our kinetics unit, if a straight line comes from concentration versus time, it's zero order. If a straight line comes from natural log of concentration versus time, it's first order. And if a straight line comes from 1 over concentration versus time, it's second order. So a cheater's easy way without a calculator is to see which one of these have even intervals between the data points. And I can tell right away that, like, for example, the concentration is not even increments, because the first one varies by 0.136 and the last one varies by 0.051. So that's not even. I know it's not that. The second one, which is natural log, you can see like between negative 0.101 and negative 1.25, it's 0.24, and then it's 0.2. That's not even either. But if you look to the one over the concentration, all of them vary by exactly 0.75. So that tells me that this is a second order reaction. And if you remember, the rate equals K times the concentration raised to the order of the reaction. So the correct answer is B.
Wait, the correct answer is what?
B.
B? I thought it was C. Wait, wait again. So you said because you flipped the reaction and that's how you got B?
No, because we're looking for even increments between the data points. So do you see what I mean by even increments?
Yeah, but like I saw like 1 over NO2.
Yeah.
And then I just chose.
You're seeing it as the graph version. But if we put it in the rate law formula, it would be to the power of 2.
Right.
Okay. I see.
Yeah, and so that's just, you probably need to go back and brush up on what that means, the order of the reaction, which is from the kinetics unit. All right, here's another one that's back from first semester. So if you remember, the key here is what's on the x-axis is energy. What's on the y-axis is relative number of electrons. So you can see that the peak for helium is twice as tall because hydrogen has 1 electron, helium has 2. That's why the peak is twice as tall. The reason that the helium one is a little bit closer to the left or a little further to the left there is because of the binding energy comes from the number of protons or nuclear charge. And hydrogen has 1 proton in the nucleus and helium has 2 protons in the nucleus. And that's why it's shifted to the left in helium, because it's got a little bit higher of binding energy. So we're going to look down and see what our options are here. So you're looking for one that states that helium has a greater nuclear charge and has 1 more electron. So the correct answer is B. Wait, let me double check that. I read through that quickly. Yes, it's B. So basically the other ones might have some true information in them, but they don't relate to what the graph is actually telling us, which has to do with number of electrons and energy. All right, so remember, before we get started on number 15 and 16, the definition of combustion analysis problems, the definition of combustion in kilojoules per mole is going to be a coefficient of 1 for the hydrocarbon combined with oxygen to produce carbon dioxide and water. And the amount of energy released is going to be the enthalpy of combustion. And it even says in the column for 1 mole of the compound. So we know the coefficient for each of the hydrocarbons is going to be 1 mole. So how we can analyze this is see how the first hydrocarbon, which is ethane, has 2 carbons in the hydrocarbon molecule. And then on the other side, it has 2 carbon dioxides. That's because the 2 carbons is going to translate over there. And we have 3 waters, which each have 2 hydrogens. So that's 6 hydrogens going to be part. So I can tell ethane has 2 carbons because of the 2 carbon dioxides and 6 hydrogens because of the 3 waters. Same thing's going to go for propanol. I have 3 carbon dioxides. That tells me it has 3 carbons. And I have 4 waters, which tells me it has 8 hydrogens. Now you're going to have to balance out the oxygens. So let's look at the products. 3 carbon dioxides each have 2 oxygens. So that's 6 oxygens for carbon dioxide plus 4 oxygens for water. So it's 10 oxygens. I get 9 oxygens from the O2. So the hydrocarbon has to have 1 oxygen in it. So let's see if we can use that information to try to figure out how many carbons are in the hydrocarbon that is unknown. Well, I have 4 carbon dioxides, so I know it has 4 carbons. It has 4 waters, each have 2 oxygens, so I know it has 8 hydrogens in it. So we can cross off C right now. Now count how many oxygens are on the product side in the 4 carbon dioxides and the 4 waters. What do you get?
Wouldn't it be 8?
You got 4 times 2. That's 8 oxygens that are involved in the carbon dioxide, plus 4 oxygens for the water. So we have a total of 12 oxygens on the product side. We have 10 oxygens that are involved in those 5 oxygen molecules. So we're just missing 2 oxygens. So the hydrocarbon has to have 2 oxygens. This is a super crucial concept. You guys see what I'm talking about there?
Yeah.
Yeah, I can see.
Okay, so the correct answer is D. In 16 states, why are they exothermic? Well, remember, you have to add energy to break the bonds in the reactants, and you get energy back when you make the bonds in the products. Obviously, you get more energy back when you make the bonds in the products. That's what makes it exothermic. So the correct answer is D. So that's basically, do you know that it's endothermic to break bonds and exothermic to make bonds? Oh, okay. We're still talking about the same substances here. More soluble in water. And soluble in water is like dissolves like. Water's a polar molecule. So you're looking for something that suggests that propanol is going to dissolve better. And that's because of hydrogen bonding. So whether something dissolves or not is going to be referring to their polarity and whether it's like the substance it's dissolving in this case, water. So you know it's propanol, and you know it's going to refer to intermolecular forces or hydrogen bonding. '18 is also interesting because you need to understand that we don't, when we're talking chemical reactions and balanced chemical equations, we're talking about moles, not grams. So you can't compare them grams to grams. So your first step is always going to be to convert them to moles. So 30 grams of ethane is 1 mole. 30 grams of propanol is only half a mole. So if you go back up to the chart, we've got 1 mole of ethanol. 1 mole of ethane releases 1,560 kilojoules. Half a mole of propanol is going to relieve half of 2020, or it's going to release 1010 kilojoules. So 1560 is greater than 1010. So the correct answer is C. Does that make sense?
Yeah.
Next one is going to be effusion and diffusion. That's Graham's law. Remember, smaller molecules move faster. So you're looking for something that states that the one with the smaller molar mass is going to move faster. Ethane is a smaller molar mass, so it's going to move faster. So the correct answer is B. Obviously, C and D are not true. We know we can compare them. And A and B are antonyms of each other. They mean the opposite thing. So that's a dead giveaway that one of those is probably going to be right. This is another one we haven't really learned yet, but the formula in your packet is the one that's relating to this problem is delta G equals delta H minus T delta S. So we know delta H is enthalpy, and we just learned that delta S is entropy. The key here is that in order for a process to be spontaneous, and when it says spontaneous, it's the fact that it happens on its own and it is favorable. That means that delta G is negative for a favorable process. So you're looking for something that's going to allow you to determine that delta G is negative. It is endothermic, meaning that delta H process is positive. So the other term has to be larger. The correct answer is D. And if that doesn't make a lot of sense right now, let's just set that aside for a minute because we'll learn a little bit more about that. But I find it's kind of like helpful if you do try to answer questions that maybe you don't necessarily know what the concepts are, but you try to take an educated guess on it. That's helpful too. And that's what we're doing with some of these. Like the next, yeah.
Me and Adam were fighting if it's B or C. And it turns out it's just D.
It's
So I don't
D.
think educated guesses work that much.
We were not fighting. We were on messages saying our answers.
No.
He's trying to make me look like I'm a bad guy.
Daniel, if you remember that.
Okay, so let's talk about C. It says that the process is endothermic in the question. Do you see that?
Yeah.
And C says dissolving the salt decreases the enthalpy of the system.
Which, if it's endothermic,
That's a positive enthalpy.
Yeah. Okay, that makes sense.
So even if you didn't know anything about this problem, you do know things about enthalpy. You could cross that off because you know if it's endothermic, the first thing you're going to write down on the paper is positive enthalpy or positive H if it says endothermic. So C is automatically crossed off.
So, Ms. Boston, if you had to make an educated guess, would you have chosen B, right? Or D? And I went with B, you know.
It's D. The correct answer is D. And like I said, this is one, we're going to take a whole class period and analyze that formula. Once you analyze that formula, it will become a lot easier to understand what's going on. That formula, because let's look at that formula. It's delta G equals delta H minus T delta S. It's in your packet, your reference packet. If you've got that in front of you, you can find that formula. Negative delta G is spontaneous. 0 delta G is at equilibrium. And positive delta G is not spontaneous. The reverse is spontaneous. So once we go through that equation, this problem, like if you understand that equation, this problem becomes a lot easier. But we don't write this second, so we'll revisit that. This will be a good one. There's a couple problems that once we learn a few of these, we'll go back and revisit these problems.
Okay, got it. Thank you.
All right, let's do 21 is what's called a buffer system. So a buffer system is a weak acid and a salt of its conjugate base. So what a buffer system does is it protects from huge changes in pHs when you add either a strong acid or a strong base. Strong acid being HCl, strong base being NaOH. So let's look at this problem as if we don't know anything about buffers. It says, A says, if HCl is added, the pH will increase. Let's cross that off right away. HCl is a strong acid. We know acids are pH of strong acids are a pH around 0. So that's going to be wrong in all cases. You can automatically cross off A because it says HCl will increase the pH. Not true. Next one says if HCl is added, the pH will decrease only slightly because H plus will react with the acetate ion. H plus is a positive, acetate ion is a negative. That makes sense. But let's go and analyze the other ones and see if that makes the most sense. C says NaOH is added. pH will increase only slightly because OH minus are going to react with acetate ions. Those are both minus ions. They're not going to react together. Remember, you have to have a cation and an anion. So 2 anions are not going to react together. So you can automatically cross that off too. And the next one says if NaOH is added, pH will decrease only slightly. Well, NaOH is a strong base. That's going to shoot the pH way up. So that doesn't make sense either. So this is a great one. Even if you didn't know anything about buffers, you do know that cations react with the anions. You do know that pHs of acids are low, pH of bases are high. So even if you had no idea what was going on, the only one that makes sense is B. even though you don't know what's really going on in that problem, does that, can you see how you could eliminate answers that don't make sense?
Yeah.
Yeah.
Okay. Let's go up to 22. We've got a mixture of H2 and O2. We've got 4 H2s and 4 O2s. That means we have 8 atoms of oxygen and 8 atoms of hydrogen. So the limiting reactant here is hydrogen. We're going to run out of hydrogens after we make 4 waters. You can count your hydrogens. Each water gets 2 hydrogens, right? So we can make 4 waters. And that's going to use up 4 oxygens. We're going to have 2 molecules of O2 left and have 4 molecules of water. Which one has 4 molecules of water and 2 molecules of O2 left?
B.
Correct answer is B. Okay, 23. That's that K and the half-life. Remember I told you they're going to throw in a half-life problem, and you've only got one half-life equation, and it says T 1/2, which is half-life, equals 0.693 over K. So basically 0.693 divided by 56. Which one of those looks like it would be 0.693 divided by 56?
A and B.
A and B could be either one of those, right? So you kind of got to do a little bit of mental math because C and D don't make sense. You can cross those off right away. So 0.693 divided by 56. You're going to do a little bit of mental math and you're going to determine that the correct answer would be A. Okay, here's our potential energy diagram. Remember just look at the graph and see what we're reading. We're reading potential energy on the Y and internuclear distance on the X. So the distance between 2 atoms in a bond is going to be the bond length. So the internuclear distance is going to be the bond length. So you're looking at bond length here. And what you're looking for is the bond length is going to be the lowest potential energy. That's where atoms like to sit, with the least and most stable energy. And that's going to be the correct answer, is going to be B. Number 25's seems like it's really complicated, but let's weed through the stuff that we don't need. So you've got a mixture of 2 gases, 0.01 of butane and 0.065 of O2. So you can kind of think of it as 0.01 is 2x, 0.065 is 13x. So we're looking for what is 8x and 10x. And the correct answer is, if 2x is 0.01, that means x is 0.05. So 13 times 0.05 is 0.065. That's for oxygen. 8 times 0.05 is 0.04. So we're going to have 0.04 moles of CO2 and 0.05 moles of water. So we know we have, if you add those together, you know you have more moles of products than you do reactants. So therefore you can cross off B because it says it's unchanged. C says it's unchanged. And so the correct answer is either going to be A or C. You have more moles of gas of the product. So is that going to take up more space or less space?
More.
Yeah, so the correct answer is A. Okay, haloacetic acid. So you have an acetate ion that is attached to a halogen, which is fluorine, chlorine, bromine, or iodine. Which compound, chloroacetic acid or iodoacetic acid, is more likely to have the lower boiling point? Well, let's see. Well, chloroacetic acid is more likely to have the lower boiling point, meaning that at a lower temperature, it's already going to be boiled. And that's going to be because of the lower molar mass, just like chlorine's a gas at standard conditions and iodine is a solid. We expect that the correct answer is going to include the chlorine. And so let's look at the different, it's got to be either A or B. And look at B says, the dipole-dipole forces among its molecules are weaker. If it was weaker dipole forces, oh no, the dipole forces are going to be equivalent. So we're looking for London dispersion forces because that's the difference between the halogens is their London dispersion forces. Correct answer is A. A COM27, an aqueous solution contains small but equal concentrations of both. Which statement comparing the percent ionizations of the two acids is true? This is also something that we haven't really done yet. In percent ionization is the stronger an acid is, the more it ionizes. So the weaker the acid, the less it's going to ionize. So when you're looking for the correct answer here for number 27 is B. Oh, it's not even talking about why. Okay. So the correct answer for that is B. That'll be something that's going to make more sense as we get to that particular part of acids bases units. Okay, which one to reach the equivalent point? Well, they're all going to have a -1 charge. They all form the same types of compounds. They're all going to have the same coefficients in their balanced chemical equation. So the correct answer for 28 is going to be C. '29 is B. We did go over that a little bit. Ka times Kb is equal to Kw. So Ka and Kb are going to be equal to each other when it's pure water. So you're just going to basically be taking the square root of 3 times 10 to the minus 14. And the power of that is what we're going to be talking about. So it's not going to be 7. You can cross that off. And we'll touch base on this a little bit more when we get further into that unit. But remember that Ka times Kb is Kw, and Kw equals 3 times 10. So you're basically solving x squared equals 3 times 10 to the minus 14th. So the square root of that is what you're interested in finding, and then the power of that. 30. You've got 2 noble gases. Changes in the average kinetic energy and the average speed. So, okay. So when you mix them together, one's at a lower temperature and one's at a higher temperature. You know, when you mix them together, then the temperature is going to even out. You're not going to have areas of a lower temperature and areas of a higher temperature. So, and we also know that helium is going to be traveling a lot faster than the xenon if they were at the same temperature. So the correct answer for 30, let me look this up. Okay, so the average kinetic energy is going to refer to how fast are they traveling. The average speed is going to refer to the temperature. So obviously the temperature is going to decrease. So you can cross off A and B right away. And then the speed, if the temperature is going to decrease, remember the average kinetic energy is going to be 1/2 mv squared. So the speed is also going to decrease too. So both of them will decrease. Remember that they're only talking about the xenon here. Which of the following best helps explain why sodium is more reactive with water than magnesium is? Well, reactivity has to do with the valence electrons. So let's see what Na is softer than Mg. That has nothing to do with it. Atomic mass, that has nothing to do with it. We're not talking about anions and cations here, so C doesn't make sense. The correct answer is D. The first ionization energy of sodium is less than that of magnesium. Sodium's got more desire to lose an electron than magnesium does. (32) Enough distilled water is added to a 30 milliliter sample of HNO3, which is a strong acid. It has a pH of 4.2. So the final pH of the diluted solution is 5.20. So remember, pH is power of hydrogen. So the power of hydrogen in this case is differing by a factor of 1. So remember, 1, when it refers to powers as an exponent, the difference of one exponent is a difference of 10 times. So the correct answer here is going to be, how much water would you add so it was a volume of 10 times as much? And the reality is 10 times as much, or 10 times 30 is going to be 300. So the question is basically asking you, how much water would you add to 30 milliliters to get it to be 300 milliliters? And that's why the answer is C.
So it's just remembering that when solving for pH, the power of it correlates somewhat to pH.
Right. So let's look, for example, like 10 raised to the first power is 10. 10 raised to the second power is 100. So that's the difference of one power is the difference of 10 times as much. So that's what you're remembering here. So the volume would be 10 times as much. So the new volume, the final volume, will be 300. You're going to add enough water to turn the volume of 30 milliliters to 300 milliliters.
Oh, okay, I got it. I think you said C by mistake. That's why I was confused.
C, yeah. The final volume is 300.
That's D.
So if you start with 30 milliliters, how much water do you have to add to get to 300 milliliters?
Yeah, okay, got it. So the answer is 300.
No. How much water do you have to add to 30 milliliters to get it to be 300 milliliters?
Okay. I see. So we already have theory. So to get it to 300, you need 270. Okay.
Right.
I understand.
So you got to remember, that's the other thing you have to remember here is that volumes are additive. So that's one of those underlying themes through all of this. Don't forget that volumes are additive. So when we're talking, when you see the word, how much water needs to be added is basically what the question is. So don't forget, you're not starting with 0. You're adding 270 to 30 to get to be 300.
Okay, got it.
All right, so oops, let me see this picture. Oh, that's for the next one. Okay. Equilibrium constant is greater than 1 at temperatures below 500. This is another one where that's that delta G equals delta H minus T delta S. So we're going to revisit this too. But it says that, so this is at low temperatures, it favors the products. At high temperatures, it favors the reactants. So we're gonna wait on this one too, so we can analyze that equation, which is delta G, which remember has to be negative for it to be spontaneous, equals delta H minus T delta S. So that's where this formula comes into play. Once we spend just an hour, even a half hour trying to analyze that equation, that problem will also become much easier.
Wait, so what is the answer for that one?
The answer for that one, oh, I suppose I should tell you that, right? This is number 33 is D.
Okay, got it.
$34 is also D. You've got a saturated solution. As the solution evaporates, 1 milliliter samples of the solution are removed every 3 days. It is observed that the sulfate in the solution did not change. Oh yeah, you can see that as the water evaporates, a saturated solution can only hold so much. So it precipitates out to the bottom, which a saturated solution is going to be essentially, if it stays saturated, it's going to be the same concentration. There's only so much that a solution can dissolve, and that's what saturated means. So the correct answer is D. Okay, calcium carbonate reacts with hydrochloric acid in reaction vessels. We're measuring the pressure of the gas. The experiment is repeated with an egg cell sample, and the experimental data is recorded in the table below. Which of the following equations best represents the species that react and the species that are produced when they are combined? So basically, you're looking to cut out the spectator ions, which you're going to produce carbon dioxide. That's what's going to happen. Okay, calcium carbonate. So you're going to look for one that's going to produce carbon dioxide, so you can automatically cross off A and C. It's going to dissolve it. I'm trying to remember what the reaction we did. If you remember on the day when I did the dry ice demos, we took some calcium carbonate pieces and we put it in an acidic solution and it dissolved it. And calcium carbonate's gonna produce carbon dioxide. So the correct answer here, let's see, not carbon monoxide. Carbon monoxide's an angry compound. It only forms when it doesn't get enough oxygen to form carbon dioxide. So that's not going to be appropriate. So the correct answer, oh, and D is, that's the total ionic equation. B is the net ionic equation. So you're going to look for the one when it says representing the species that react and the species that are produced. You're going to look to cut out the spectator ion, which in this case is the chloride. So the correct answer for 35 is going to be B.
Miss Boston,
Yeah.
for 35, how would you know that it would produce CO2?
Well, you know it's going to produce a gas, right?
Mm-hmm.
So you're going to look for a super happy gas.
Oh, and then CO versus CO2 are complete. Yeah. Okay, that makes sense.
Let's see, we got to figure out the mass percent. Let's see, we had 2 grams. 0.2 grams of eggshell. And I'm trying to. So you can do your pressure at the completion of the reaction. You can do your PV equals nRT. Next time I'm going to try to find a way where I can actually write on my pen. I thought it would, but it won't write on here. I'm going to see if I can maybe take some of these where we would want to put the math down and maybe copy paste them onto a Jamboard or something so you can see me do the math here.
Yeah, that would be good.
So let's make a note of that because you've got the mass of the eggshell sample and you've got the pressure at the completed reaction. So we'd have to do some simple math here. Mass of CO2 in grams. Got it. So let's circle that one and I'll do the math for you. The correct answer is D for that one. But it's going to be kind of tough to explain without a pen and paper. Same thing with D. We've got basically half the amount. If you'll see, everything was half. So you go up to the original and it would be half of 2 molar HCl. So let's see, what is that? Correct answer would be D. Now 38 is reaction rates. If you remember the things that increase the reaction rate, and we did demos for this day too, is concentration, temperature, catalyst, and particle size. Can anybody see any of those that would increase the reaction rate?
I said C.
Is the reaction endothermic?
The reaction is exothermic.
So wouldn't it be B then?
Yeah. Correct answer is D. It's talking about increasing the rate of the reaction the most. So when it says increasing the rate of the reaction the most, look for something that increases the concentration, increases the temperature, or increases the surface area, or maybe mentions adding a catalyst. So the correct answer is D. Because A, we're talking about the same concentration. B, we're talking about cooling. That's going to lower the reaction rate. Reducing the volume of the reaction vessel. If you reduce the volume, now we just learned this, look at the balanced chemical equation. If you reduce the volume of the reaction, are you going to produce more gas or less gas?
Less.
You would produce less gas, so it's not going to increase the reaction rate. It's going to stay more as reactants, not products, because you're producing gases. Reducing the volume is going to allow for less production of gas. Hang on one second. Sorry, somebody's phone's ringing. I'm just going to wait until their phone stops ringing. We're on number 39, right?
Yeah.
Okay, samples of sodium fluoride and ammonium chloride are dissolved in separate beakers that contain 100 milliliters of water. One of the salts produces a slightly acidic solution. Which of the following best represents the formation of an acidic solution? So A, sodium's a notorious spectator ion, so it's not going to be anything that reacts with sodium. The correct answer is we're looking for a slightly acidic solution. So we're looking for something that is going to react with water. We can automatically cross off A and D because those are part of, A is part of a strong base and D is part of a strong acid. They won't react with water. A with sodium is a spectator ion. C with chloride is also a spectator ion. B, if you look at it, remember our acid-base neutralization reactions? Remember our acid-base conjugate pairs? If you looked at B, the strongest species there is going to be the hydroxide, which is basic. So if you're stuck between B and C, B would be a basic solution, C would be an acidic solution. So the correct answer for 39 is C. Man, this one's heavy in that delta G stuff, huh? Okay, so
honestly, like, I think I'm gonna have to like study that unit extra carefully.
yeah, honestly, the one thing I'm going to tell you, at least with the delta G's, we're going to break it down into a few simple pieces. And once you get to that part and you learn about that equation, and we spend one period picking that equation apart, you're going to be like, oh, you know what? This isn't as difficult as I thought it was going to be. So don't stress about this. But let's look at this and note that, okay, delta G in this case is negative. That means this is going to spontaneously happen. So in theory, when you take diamonds out of the earth, they should spontaneously turn back into graphite. Now, we don't see that happen. Is it because it would take a very, 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 very long time to do? We don't necessarily know that we would ever see that happen. So let's look at this. A, the rate of reaction is extremely low because of the small value of delta G. That's not true. It doesn't, this is not related to speed. There's nothing about speed in this reaction. And that's the thing about spontaneity. You can tell whether a reaction is going to happen spontaneously or not, but you cannot tell how long it will happen, how long it will take to happen. So we know lots of spontaneous reactions that happen super quickly. Just like when you breathe in oxygen, you also know lots of spontaneous reactions that don't happen super quickly, like the rusting of iron. So anything that talks about slow versus fast, automatically cross that off. Says the entropy of the system decreases because the carbon, well, that would be a reason to say we do see it observed. If B was correct, we would see that happen, but we don't. It says we don't see it happen. So you can cross B off also. It is not thermodynamically favored. The correct answer is C. This reaction has an extremely large activation energy because of the strong bond, and that's why it doesn't happen. So the correct answer is C. Again, we'll pull this out and revisit all these delta G ones when we get to it. This is acid bases, which we introduced a little bit at the equivalence point. So we're talking about 2 × 10⁻⁴ of acetosalicylic acid dissolved in 15.00 milliliters of water, titrated to the equivalence point, which is true at the equivalence point. So what's going to happen is in the beginning, you have acetosalicylic acid in the flask, and then you have NaOH in the beaker. I mean, in the burette. So I did just a brief introduction to that. So in the beginning, you're going to have the most acetosalicylic acid as you are ever going to have. It's going to be in the flask. Then we're going to start adding sodium hydroxide to it, and the reaction will start happening. So the amount of acetosalicylic acid is the most in the beginning, and it's going to decrease as you add NaOH. So it's going to be the most in the beginning, and it's going to be the least at the equivalence point and beyond. So D is not true. At the equivalence point, they can't be equal. So the correct answer is B. We're going to have less. When we start picking apart titrations a little bit more, that'll be easier also. pKa is another one we have to talk about a little bit more. But you can imagine, you know what pH is? pH is power of hydrogen. So you can imagine what pKa is. pKa is power of Ka. So pH and pKa are related in that they have the same formula, which is the negative log. So pH is the negative log of H+. pKa is the negative log of the Ka. So I can tell how weak or strong an acid is based on its pKa. But let's go the approximate HOC bond angle. Remember that this is not a linear bond there. Its electron geometry is tetrahedral, but 2 of the spots have lone pairs of electrons. The other 2 spots have bonding pairs of electrons. So the angle's not going to be 180 and straight. It's not even going to be 109. It's going to be a little less than 109 because of Vesper, it's going to warp those bonds down. So you have 4 spots around it, but remember I said absolutely not even though we've drawn it like this, remember it is not 90 degrees. The correct answer for 42 is going to be C at 105. So if all 4 of those spots were taken up by bonding pairs, it'd be 109.5. If 3 of the spots were bonding pairs and 1 was a lone pair, it'd be 107. If 2 of the spots are bonding pairs and 2 are lone pairs, it's 105. Now it says, what are the following true is about the geometry? Okay, so you can see that carbon with the double bonded oxygen and the other oxygen in the OH, that's going to be that trigonal planar. It's going to lie on the same plane. So that's what you're going to look for, is that they lie in the same plane with trigonal planar, 180 degree bond angles. And that's what the planar means. It lies flat on the paper or in the same plane. Let's see about this kind of goofy looking ion. Well, you've got, remember those brackets? When we draw ionic compounds, you put the anion in brackets with a negative charge. You put the cation with a positive charge, and that indicates to you that the electrons have actually been transferred from the cation to the anion. So that's, you're just going to say that that's ionic. The correct answer is A. It is soluble because it's an ionic compound. It's ionic compound, so it's a solid at room temperature. It doesn't evaporate easily. It has a high boiling point and a high evaporation point. And it dissolves, but it's not going to be acidic. So the correct answer for that one is A. So those brackets and the cation and the anion should tell you ionic.
Wait, Ms. Boston, so 43 and 44 are both A?
Let's see, 43. 43 is B.
Oh, okay. And then 44 is A. Okay, got it.
Okay, we've got pictures of carbon tetrachloride. Okay, remember this is the one where this is tetrahedral, and if you have a tetrahedral compound that has all 4 atoms on all sides the same, it is symmetrical. So this is a nonpolar molecule. So we're looking for London dispersion forces, which another word for London dispersion forces are temporary dipoles. So when you're talking about holding the molecules together, that's your dead giveaway for intermolecular forces. So you can cross off A and B because those are intramolecular forces. Permanent dipoles would come from polar covalent molecules. Temporary dipoles come from nonpolar covalent molecules. So the correct answer for 45 is C. (46) What do you need to know to determine the enthalpy of solution for KCl in H2O? That was in our thermochem. So remember, our MCAT equals MCAT. So the amount of water, so it's mass, specific heat, change in temperature. So you're going to need to know the masses of the substances and the temperatures of the substances. So how can we cross off some? Let's see. Yeah, you need to know both masses. Because if you remember that MCAT equals MCAT. So we can cross off the ones that don't say both masses. And then D doesn't make sense because it's talking about the atmospheric pressure. Pressure does not affect solids, It does not affect liquids, and it does not affect aqueous solutions. So pressures are going to be something we look to determine if we're dealing with gaseous solutions. So the correct answer is C. X2, Y2, and XY in a rigid container would lead to the formation of more products as the system reaches equilibrium. This would be another one that's going to be good if we have oh, I see. Okay, so I didn't see the equation above. Kc is 3. So does that favor the products or the reactants? So what you could do, you could either do the whole equilibrium mixture, say K equals xy squared over x2 times y2, and solve for each of them if you want. But in general, you know that you want to have more reactants and less products, and then it'll shift towards the products to make more products. The other ones, you could do the calculations to double check yourself, but you know the more reactants you have and the less products you have, the more it's going to shift towards the products to make products. So that's basically what they're telling you. You could also do one of these things that's not like the other. Notice that B, C, and D have less reactants and more products. And A is the only one that has more reactants and less products. We know that this favors the products, so that's the one that's going to shift towards the products. So the correct answer is A. Okay, isomers means the same chemical formula, but different molecular structures. So if you notice that these do not rotate because of that double bond. So in the cis, both of the chlorines are in the same side of the molecule. In the trans, they're on the opposite. So you've got some symmetry in the trans along one axis, whereas the cis is going to be a polar molecule. So the correct answer here is going to be D. So polar has dipole-dipolar. Nonpolar or symmetrical molecules have only London dispersion. So basically they're asking you, do you know that a higher vapor pressure comes from the weaker intermolecular forces? So the stronger the intermolecular forces, the lower the vapor pressure, and the lower the weaker the intermolecular forces, the higher the vapor pressure, the more likely it is to be able to escape from the liquid phase. All right, 2 left. This is a KSP. This is coming next. This is the tail end. This is actually the next thing we'll be learning about. The correct answer for 48 is D. And this is going to be the next step in which is KSP. It'll be easier. It's just an equilibrium problem, but it'll be easier to understand after we talk about it. So it's the same stuff we're doing now. It's just one little extra piece that we need to discuss. And here's another delta G. Honestly, guys, I don't think I've seen a practice test that's this heavy in delta G. But let's see if we can, based on what we know, formation is not thermodynamically favored. If it is not thermodynamically favored, that means it's endothermic. We can also look up there. You can decide that whether it's the first one, is going to increase in entropy because the first reaction we have only solids in the reactants, but we have gases in the products, so that's going to increase in the entropy. And in order to figure the KEQ out, you're going to have both of those equations together. And then delta G is spontaneous. This reaction will happen if it is delta G is negative. So we're already between B and D. The correct answer is D. And that's another one I'll circle that as soon as we know a little bit more about delta G, that we'll run through there and just clarify what those answers mean. Okay, that's all 50 of them. Is there anything you want to go back and revisit real quick, or you think that's enough to fill your brain for today?
So, Ms. Boston, like, are usually like, is this just happened to be no calculator, or is there like, is this just like every year they change it, one with a calculator, one with no calculator? How does it work?
There's different sections. So there's different sections of the AP exam.
Wait, so this 50 questions, it says like an hour and a half to complete. So this means there's another hour and a half to complete with the calculator?
The other sections, the rest of the test will be calculator.
Okay. That's that for Q, right?
Yes.
Oh, I was gonna say. Like 2 tests and an FRQ?
Yeah, like 2 tests and FRQ, that's scary. But honestly, like, this test is really heavy on delta G. Like, I'm now scared of G forever. I can never recover from the letter G.
You know what? Like I said before, I swear you'll probably agree with me when we get there. If it was heavy on delta G, then it would probably be a little bit easier to understand if it was heavy on delta G, because delta G is a fairly straightforward. There's like 5 things that you need to know. They'll be like the gospel of delta G, and I will tell you what those things are. And it will be one of those units that's fairly straightforward, at least in my opinion.